If you look at like the cross section of a solar company building, half of the people, half of the headcount are like never in that building because they're field technicians. And then the other half is white collar on paper, but these are like mom and pop shops. And so the hard part to what we do is really coordinating the internal stakeholders, the external stakeholders, and then of course the equipment itself, the hardware, because most hardware, they're called OEMs, like with cars, original equipment manufacturers, and they're always trying to squeeze out these solar companies to basically just be like that asset heavy source of labor, like a tech. We believe in a world where these contractors are in a unique position to be the next generation of utility companies. And so we want to empower them from this kind of very primitive technological state to a level where they have everything to develop, deploy, and maintain these assets.
Hey Max, thanks for joining me today.
Hey Brett, thanks for having me.
Maybe we could start off by telling everybody what Coperniq does.
So Coperniq is building the infrastructure for the distributed electricity grid. So usually when I tell people that at cocktail parties, they think that I'm either with PG&E or maybe we're material scientists working on, battery chemistry, or we're just like door-to-door solar salespeople. People in California get to get those a lot. So we're actually none of the above, but we're kind of the invisible workflow glue that connects all of those actors together. So as you may know, America right now is undergoing a second wave of electrification. So the first wave started in the 1880s, Westinghouse, Edison, AC versus DC, the current wars. It's actually a pretty good movie. You might like the Rotten Tomatoes is like 33%. I watched it. I was like, no, this is actually not bad. And so that was basically centralized power plants, wires and poles, distribution lines, transmission lines, and just running electricity to the point of consumption. Now we're seeing the second wave of electrification where there's EVs, heat pumps, batteries, solar panels. They call them DERs, distributed energy resources. And Coperniq is essentially an end-to-end asset lifecycle software that helps connect all these stakeholders that are needed to develop these projects, basically sell them, deploy, construction management, and then monitor the 20-25 year asset lifecycle. Because again, contrary to popular belief, solar is actually not low maintenance. So there's a lot of repeat site visits and a lot of kind of long tail monitoring. So Coperniq tries to do all that from a software layer, but we're increasingly starting to rub up against some of the weird and wonderful hardware stuff. So I'm sure we'll get a chance to talk about that.
Yeah, that sounds great. And so what brought you to this problem? Like maybe just take a bit through your background and how you ended up here.
Sure. So my background is I moved to California, originally from Russia, got into college, then transferred from UCSD to Berkeley. And during transfer orientation, ran into my now co-founder, best friend, CEO, Abdullah, who was studying energy engineering. He, out of the two of us, was the one kind of scratching the itch and with industry experience, if you will. He worked at a solar company in a project management role, essentially. And he had witnessed firsthand how that was a company that was very ethical, very moral. They were trying to do everything by the book, but they still had a lot of customers left in the dark with poor communication issues because they were very rustic in terms of their back office, a lot of pencil and paper, Post-it notes on monitor screens, that sort of thing. My first encounter with solar was more from the end consumer side. My grandparents went solar around 2015. And they just had, talk about buyer beware, like the worst possible experience with their solar company. They try to sell them more panels than they needed, all kinds of shady, sales tactics, and then just a horrible process that ended up taking them almost a year instead of like the promised 90 days, 120 days. So we connected the dots. And I remember to this day, one of the first things Abdullah showed me during transfer orientation is he pulls out his phone, shows me the Tesla mobile app. He's like, hey, Max, you study computer science, right? Could you build this? Like, could you build this, bro? I was like, yes, bro. And I I had no idea how to build mobile apps, web apps. That's not the kind of stuff they teach at UCs, even though it's computer science. But we figured it out. And fast forward to today, we pretty much have a multi-product platform that combines everything from CRM on the front end, field service management for dispatching technicians, project management for the back office stuff, and then this kind of long-term asset lifecycle management.
Wait, sorry. Literally the first time you met him, he had this idea in his head, and he was like, "Can we modernize the software stack here?"
So we didn't know if we were going to be a Tesla competitor or a Tesla 2.0, but he was really fixated on Tesla. I guess for him, it's a little bit about Abdul's background. Born and raised in Yemen, and then when the war broke out, just his whole city, his village was devastated. The electrical infrastructure was compromised, so him and his uncle had to jerry-rig a DIY solar system. And so that's where he saw kind of the magic of DERS firsthand in the trenches. And then he wanted to come to Berkeley and study it, at the highest caliber, and then start a startup and do something, Tesla adjacent, because that's when one of his internships was. And he quite literally approached me with that. True story.
And then as articulated from the onset, like the problem space was more about like market structure and like existing players and just like legacy systems, right? Is that like how to think about it correctly? Like you were like, they're just kind of bad actors in the industry that are able to get away with that because of lack of efficiency, and B, there's just like lack of efficiency broadly. It's still kind of like what people thought of as like a file cabinet industry where people were moving paper around.
Yeah. So pretty much, and the way we kind of conceptualize it is like, imagine this, it's a triangulation problem. So like at the top of the triangle, you have the home or business owner, right? Whoever is getting residential or commercial electricity. And then if you look at like the cross section of a solar company building, half of the people, half of the headcount are like never in that building because they're field technicians. So these are like your kind of the service titan crowd, trucks in the truck, like folks that climb on roofs in 120-degree heat in Sacramento, just to put glass on the roof as they call it. And then the other half is white collar on paper, but these are like mom and pop shops. Some solar companies are publicly traded, like think Sunrun, right? But most are really SMBs and kind of a long tail cottagey industry. And so the hard part to what we do is really coordinating the internal stakeholders, the external stakeholders, and then of course the equipment itself, the hardware, because most hardware, they're called OEMs, like with cars, original equipment manufacturers. They're kind of on a mission to vertically integrate, and they want to be the next Tesla, so they want to own everything and control everything from the labor to how the technicians get dispatched. And they're always trying to squeeze out these solar companies to basically just be like that asset-heavy source of labor, like a tech. We believe in a world where these contractors are in a unique position to be the next generation of, utility companies. And so we want to empower them from this kind of very primitive technological state to a level where they have everything to, develop, deploy, and maintain these assets.
And then did you have an immediate intuition that like cutting across the different parts of the life cycle from like sales to implementation to maintenance was one product, and or cutting across like horizontally against different, I guess, modalities of generating energy was also a similar problem? Or did that like come together as you went?
Yeah, that's interesting. So it was definitely well, I remember the first time we got rejected from YC, it was Nicholas of Algolia. He said, you guys are trying to do too many things at once. This was like circa 2019, 2020. You're trying to build a field mobile app, like a React Native app. You're trying to build 2 SPAs, like one SPA for the office workers, one white labeled portal for homeowners. And you're trying to build like a backend, a platform for all this. This is too much. Like the conventional wisdom at the time was build a point solution and then kind of land and expand.
Wait, define SPA.
A single page app, like a React app, right? Just the front end, multiple basically surfaces. And we were, I guess, crazy enough. Part of it is probably because, and this is like a blessing and a curse, speaking of engineering, because neither Abdul nor I had any kind of deep Silicon Valley industry experience. Yeah. That was both a blessing and a curse, because on one hand, we didn't know what we were doing. We were, I guess, crazy enough, ambitious enough to dream big and think like, let's just build ourselves a little mini ERP out of the gate, like anti-MVP style. But at the same time, in terms of, hiring and finding engineers, finding talent, neither of us had a deep Rolodex of Fang Mang engineers. So we had to kind of build everything from the ground up. And I was saying like, they didn't teach about mobile or web development in Berkeley. So I kind of had to learn everything building Coperniq.
So at the same time, there was some intuition about like the scope of the problem at scale, but it may not have fully informed early engineering architecture because there was just kind of a lot going on.
So we were still trying to take a slice of sort of broadly speaking, the deployment or the project management phase of the full asset cycle, that was mainly Abdullah's intuition at the time, because he had seen how the top of funnel like problem of getting solar, selling solar was pretty much solved. Like it's already crossed the chasm, at least in California and Arizona and Hawaii and the big pioneering states. Even though there were a lot of like everyone was knocking off Aurora Solar at the time and building these essentially vertical CAD design tools to sell solar. And then similarly, like on the back end, on the hardware front, there were a lot of people trying to do all kinds of energy monitoring, battery monitoring systems. And we were like, okay, let's try to not do hardware for as long as we can. But that left us with this kind of weird middle ground of, well, these projects are actually hard to deploy, because most of the people working in these companies, it's like an identity crisis thing. Half of them are former salespeople that used to like door-to-door sell solar. It wasn't Tesla back then, it was Solar City, but kind of same thing. And then the other half were your traditional salt of the earth electricians, like mechanical, electrical, HVAC, contractor folks. And so solar encapsulates both of these worlds. So you have to be very good at construction and field, service management, but at the same time, there's a lot of project management, a lot of moving pieces, think like Gantt charts, dependencies, especially in a state like California where there's all these hoops to jump through and the policy shifting all the time. So we kind of landed on, let's be really good at the construction project management part, and then we can always go up, down, the value chain from there.
Yeah, that makes sense. I mean, it's sort of like layering on other logisticals. And so like how, I maybe like take us back to how do you start? Like you have this initial prompt of like the Tesla app, you understand this problem in this pain point. Was it a matter like were you going out and talking to a lot of people and figuring it out, or like, how did you iterate on early designs of the product?
So we started iterating right around the first or the second wave of COVID. So we were doing these, I kid you not, curbside presentations. So that was one of the prospects. It's like, I've done curbside pickup, but I've never gotten a curbside software presentation. So we were, again, crazy enough to go and start. We didn't have sales experience. We didn't have, tech insider experience. So I remember myself pulling up, an Abdullah's Prius at the time to just like a random, like throw a dart at the map, hit up the first random solar company, pull up with a Figma, kind of like Figma sell first, build later. And we're like, hey, do you want to check out our, I think it was like a Kanban board at the time. And then you could toggle to like a spreadsheet view. And that was it. And that got us our first few customers. And then we were essentially like on an exploding pilot where we had to build something, ship something in, I think it was 90 days. Again, agile estimation. Nobody knew. We were like 90 days, whatever. Like we'll build it by the end of the summer. I think one or two buttons maybe were working. Like the Kanban table toggle was working during the final demo, but yeah, we somehow worked.
Wait, was it just the two of you at the time?
Initially, it was the two of us because, like I said, got rejected by YC. We were like, okay, we'll just keep applying until we get in. And in the meantime, we were like, well, let's just kind of bootstrap this. So I was doing a lot of the early coding. I was lucky enough to have a couple folks just like in the Bay Area community, friends and family folks who had worked in the industry, to basically tell me to keep it simple, silly, and use the most opinionated frameworks that we could find at the time. That was Nest.js or with TypeScript, and so we kind of try to roll as little of our own, infra, DevOps, and architecture. And that's how I think in the early days, we were able to build a lot of product surfaces, a lot of backend, API surfaces very fast. Didn't test anything for the first, 9 months, maybe 12. And then that started backfiring in all kinds of fun ways. But yeah, we were at least able to get like a ERP parity, ERP light product to market and just iterate on it from there.
But you had so you were just like thrown into the deep end on this. You didn't have really product experience. You had studied some CS, but...
Studied CS, took a UX class. I mean, Steve Jobs has the calligraphy story. For me, it was a little bit more applied. It was UX probably was the most valuable class. It was like HCD and UX or something, and really understanding different modalities. That helped a lot, mostly in terms of this like persona or demographics issue, where imagine the technicians in the field. This is quite literally 120 degree heat, Sacramento or Texas or wherever. The panels are basically hot sand. You get second degree burns if you touch it. They heat up to like 160 degrees. Your phone is going into like energy saver mode. Crack screens like Android, whatever, Jelly Beans, Android 12. And that combined with like the data that they collect in the field, and basically our mobile app is like, oof, it is their like handset device, which had to be a time clock, a photo capture, device, a geofence, and just like a general schedule view of like where are they going, and like a dispatch kind of to-do list. So we had to stuff all of that functionality into the mobile app, and what we ended up with is we were like, okay, let's have web parity, and we quite literally just try to compress all of that just down to the real estate that we had on screen, and then the technicians simply wouldn't use it. They'd come up with every possible excuse in the book just to like eject to camera roll and to just sending photos to their project managers via email, because it was just so much functionality. And that's where, going back to the UX class, I figured, okay, how do we carve out a different slice and just focus on, the jobs to be done and the user flows for these technicians, so that they can just, essentially so the phone becomes like a data tap and just a source of truth for these pictures, for this multimedia. And it really doesn't do any of the stateful kind of workflow heavy stuff. All of that stuff happens on the web and on the back end with the platform.
So in a way, like you kind of designed it from the top down, but then you just matched it to the workflow that was happening.
Yeah, I think there's still, if you scroll back up or down, whatever direction the infinite scroll is on the App Store, you'll find one of our early patch notes is like, finally web parity. And then like two patches later, it's like, stripping down to like just the bare bones photo capture, flow or what have you. So we definitely learned the hard way in terms of building multiple presentation layers, I guess, different UIs for different personas, but still delegating all of the orchestration, all the heavy workflow stuff to the back end, and honestly kept it invisible. That made us take a hard look at the web interface itself and be like, most of this stuff should just work like magic. And this is like pre-LLM magic. This is just like, they don't know how it works, just black box style, but it does.
Yeah. It's kind of, there's always this insight where you're kind of like, you build something and the users don't get it and it's your fault.
Exactly.
And the more users you interact with, the more you like internalize that is like the kind of the design principle, that it's like never really on them. And so, all right, fast forward today, like obviously like much more complex system. Like what, how far have you come? What have you learned?
And so speaking of, you sometimes take something into the wild and then the genie's out of the bottle and you try to figure out how to undo some of these chaotic loops. At the core of Coperniq is this, workflow engine, right? And this is not your kind of stateless, if this then that, like Zapier style automation engine. This is much more of like, think, what's the Microsoft Dynamics, like Process Studio or like ServiceNow, right? Where you have basically like a time, a dimension, and you have multiple phases that can be serial or parallel. And there are different elements that have to happen, again, sequentially or in parallel. Dependencies, blockers, conditional logic, all kinds of things. Going back to like the essential complexity of the domain of like, there is, in order to get solar legally on a roof, you have to first, sign a contract, sign all kinds of addenda, all kinds of interconnection agreements for PG&E, SDG&E, with your HOA, just like all the paperwork that also has a very strict, that is like, path dependent. And then from there, you have to get engineering, which is where like the whole philosophy of, we sometimes call it like Procore Light, like building a light construction, just enough construction management features. And then from there, you have to get, the engineering professionally stamped by like the plan set stamped. Then you have to apply for a permit. Then you have to do the construction, which oftentimes you're rolling the truck twice because you're first doing like the electrical and then you're doing the panels, or vice versa, depending on how you want to go. And then from there, you kind of, hurry and wait because there's an interconnection backlog with PG&E. It could take, 6 days. It could take 60 days. So, a lot of stateful workflow complexity, despite people, a lot of people think of solar as just kind of high voltage, appliances or like a medium-sized home improvement. It's actually a mini construction project, a mini home improvement project. So all of this is to say, I remember the first version of the workflow was not backward compatible, didn't have any version control, didn't have anything, and yet we had people using it. And so then we spent almost 6 months to a year rebuilding this like fancy workflow with better UI, drag and drop, and like a diff engine and version control. And then the problem was, okay, well, how do we migrate users now, right? All of a sudden, for net new customers that were, we were booking from that point on, they were like, oh, we love this. This is amazing. How could we live without this? But for those legacy users, a lot of the time, like I remember when we ran the migration, all of a sudden, all these like ghost work orders from the past that finally propagated because of this new, a job queue mechanism appeared out of nowhere. Some of our customers and clients receive notifications that, oh, hey, your project is finally entering site survey when it's like been installed for 3 years. And like, are you trying to scam me? What's going on here? So there's a lot of interesting, like once something's in the wild, it's still deterministic, but it feels chaotic because, with stateful processes like that, it's just sometimes really hard to wrangle them in. And that's just, on the business process automation front. We got good at that. Much better, at least. What's more interesting is the hardware aspect, where again, I remember from day one, we were like, we're not building any dongles, any, service, smart panels or anything, at least for as long as we can afford not to. But we still had to integrate with all the, hardware vendor APIs. And they don't want us integrating with them because they're on a mission to be vertically integrated and have kind of a walled garden approach to integrations where you can read very infrequently, but you can, for example, write. You can't like control the battery, right? Because everything's about dispatchability, right? Like solar is just the first mover, first domino, but utilities are not going to get on board with solar until there's batteries and until you can actually, buy or sell electricity on a certain schedule. So that's control. And most of these OEMs, they don't expose control endpoints unless you prove that you're a partner or unless you go down all this, biz dev. So we're just solving the monitoring problem alone with read functionality was already super powerful because most of these installers, they get the solar commissioned and then they actually have no idea at any point in time out of a fleet of like 10,000 systems, what's producing, what's not. And it creates this really bad customer experience because the customer doesn't know either. And how does either party find out? Well, at the end of the month, the utility company, take PG&E for example, sends them what's called a true-up bill, right? Which is they thought that their electricity was being paid for by their solar, but actually this whole time, I don't know, an inverter was out and something was underproducing or not producing at all. Like that system was completely dark, and nobody knows about it. So that's why just being able to build kind of a poor man's Datadog for these solar assets was already a big win for us, and we were able to do that just with essentially like polling with hourly, 6 hours, whatever. But now the next move for us is going to be how do we actually figure out a way to control these resources, and it's definitely not going to be by integrating with the OEMs. So it looks like we may have to build a dongle after all. But that's just kind of how the software is presenting a new hardware challenge, right?
Wait, how many different like OEMs are there? Like, what is the actual scope of trying to integrate with all these? Are you having to spend a lot of cycles on any given one to like try to figure it out? Are you actually reverse engineering things, or is it?
Yeah, that's interesting. So the reason why I called it like a poor man's Datadog is because we had to build our own data ingestion pipeline, and this is like this was already 2.5 years into building Coperniq, and we figured out, we were so proud of ourselves. We were like, okay, we barely figured out how to build just like, transactional, CRUD apps. And all of a sudden we're like, wow, we have to do telematics and time series databases are a whole other, can of worms. Again, had to resort to the keep it simple, silly principle. And thankfully, Postgres has a very rich ecosystem. So if anyone's building anything with telematics or IoT, highly recommend Timescale DB. It's like a plugin, and then there's a cloud version and an on-prem version. Basically, it allows you to have a time series data in your otherwise SQL database. So we had to learn kind of a whole new tool chain and we had to get good at ingesting data. You mentioned how many OEMs. There's a lot. It's a wild west, really. Even though it's like very much a duopoly market where it's Enphase and SolarEdge, they kind of control most of the market. Tesla, of course, is attacking the market pretty aggressively, but it's like a 80-20 distribution. But every one of those OEMs has a completely different protocols, from like MQTT, or some of them you just have to poll, like And then, the granularities all over the place. Some will give you like, minute by minute granularity. Some will just roll it up and give you like hourly granularity. There was an interesting story there where one of our engineers just, flipped a bit, as they say, and confused 15 seconds with the Unix time clock with the asterisks. And should have probably looked it up or asked ChatGPT, and lo and behold, we ended up just overflooding the ingestion. Found out what back pressure was the hard way, because we were ingesting it thinking it was 15-minute granularity, even though it was 15 seconds. So we had to build all kinds of, ETL pipelines and things like that. But again, always on a budget, always on a napkin, and without any experience building like distributed systems or anything like that. So always leaning hard on like the tools that we had. And I think because we made a lot of good ecosystem decisions early on, like sticking with Node, Nest, TypeScript, Postgres, we didn't have to look very far in terms of what is like the globally optimal solution for this like very known problem. So most of the time we would just take these off the shelf solutions.
And was it like, did you have to like try to figure out how to address like the majority of the market, or was it just more like reactive to like customers are using this device, we better work with that? Like how did you think about prioritization?
So it's interesting because most of the consumer market demand is actually not dictated by, it's kind of like the whole thermostat market. Like homeowners don't actually choose what thermostat, like Nest had a problem with this in terms of going to market. It's really the contractor. And solar, it's even more, it's higher up in the value chain. The distributors, not like distribution lines, but the actual like wholesale distributors, basically have these special purchase vehicles, and buy panels or inverters in bulk, and then they give essentially different pricing based on volume to the actual installers themselves. And most installers, mom and pop shops at least, they don't even warehouse. They just kind of have the equipment drop ship on site. There's another funny story there if we have a second. I remember in the early days when we had our first customer in Canada, and we were just still figuring out how to use Google Maps to normalize addresses. And because this was a new build, a new project, there still wasn't like a latitude longitude coordinate on Google Maps, and so it got normalized, like it snapped to a house in the like adjacent cul-de-sac. And because of that, the crew that was installing the equipment that day almost installed solar on the wrong house, where like the homeowner ran out, kind of get off my lawn style, what are you guys doing? And then they're like, wait a minute, our software said that it's 123 whatever Grove Street. So just little things like that, right? But where were we? Yeah. So speaking of OEMs, there's really these 2 or 3 big vendors, and they're primarily, the demand is dictated by the distributors. So between the 3, we essentially were like, okay, let's have a most favored nation kind of mindset, where we're going to build these 3 plugins, connectors, like think adapter pattern, and the next time when we have to do the N+1 or the 4th one or the 5th one, we're going to be like, is this Tesla-esque? Is this SolarEdge-esque? Is this Enphase-esque? And kind of like not over abstracting, but at the same time having some, a little bit of a shim, a little bit of a thin layer of abstraction, and then being able to kind of just, quickly N+1, the next vendor and the next vendor and the next vendor. That was something that I think we got right. One of the few things we got right the first time around.
Yeah. Wait, and so when you say get in a dongle, you mean like you might have to put your own hardware in the loop between, like as a control plane on before that actually controls this the end power generation?
It will be valuable even for monitoring, because if we look at the case study of commercial assets, there's a company in that space called Also Energy. I think got bought by STEM. Point is, they are very much like a SCADA. I don't remember. Is it supervisory control and data acquisition, like some acronym from probably Department of Defense. And they basically have this data logger, which I think it's basically like a current transformer, and it is super precise. You can see the consumption, the production, the power, the energy, and so you get that super precise like circuit level telemetry. I don't know if they actually have a control point, but yeah, they could have probably with their scale integrated with a bunch of built out a bunch of connectors, like Datadog style, right? Like a Linux, a Windows connector, and still they chose to basically roll their own hardware. Again, it might be white labeled, who knows? But the point is just not having to worry about integration and not having to worry about essentially one day it becoming a walled garden to the point where you get an email from BizDev saying like, hey, I'm sorry, like your API key is now rate limited to once a day, right? When you need to be like in that ideally sub 1 minute, once every 5 minute range, if you really want to start participating in some of the demand response markets. Because there's something called FERC 2222, which is basically this policy that starting from 2026, they're going to be piloting, I think, on the East Coast, and it's going to come to the West Coast for residential, like sub 30 kilowatt systems to be able to dispatch, so like basically sell electricity back to the grid. They need to have sub 1 minute telemetry, right? So that's kind of where that that's a natural filter. And if the OEMs won't let us integrate at that level of granularity, we're probably going to have to, like white label a box, and then I mean, just frankly, we don't even know what the unit economics of hardware are, and that's why ideally, like the longer that we can afford to not have to mess with hardware and focus on software, because it's hard enough, the better. But probably one day we'll have to.
Have there been places like along this journey, maybe, I don't know if the integrations or somewhere else, where you like felt like you were hitting a wall with what you're building, and then you actually like weren't sure you were going to get through the other side and figure it out?
Yeah, one thing that comes to mind is, so going back to the 120 degree rooftop, the mobile app there, problem is in most states there's something called the solar mandate, which is basically all newly constructed housing has to have solar, at least in California. And so a lot of these sites are either like projects that are being newly developed, or like HOAs, basically new development. A lot of the times, not only are these sites not on Google Maps, where like we could normalize the address like I was saying earlier, but there's quite literally no cell towers and no reception there, right? And yet the mobile app needs to be online ideally, because again, we're geofencing them, clocking them in and out, capturing photos, and backhauling all this multimedia like to our main server. So we had to, I remember initially we rolled out the first version of the mobile app. It did all those things like in a lab conditions, but in the field, like just even with 1 bar of signal, it would not even open, right? Yeah. To the point where we had to really learn the hard way what's it like to actually make an offline first mobile application, and kind of had to reinvent a bunch of little wheels along the way. Because I think with the React Native ecosystem, at least, there's a lot of great off-the-shelf solutions, but you need to introduce like, okay, you need one library for a key value store. You need one to handle like the low-level GPS and radio modules. You need another library to do kind of these like health checks with the server. So we were lucky enough to have a really, really good mobile developer. Just essentially a one-man show for the longest time. Just hired a second mobile developer literally 6 months ago. For the longest time, this one guy was basically doing all of those various kiosks and features in one app. Yeah, like I was saying, the first version, we took it to market, and most technicians they weren't boycotting it, but they would just try it once, and then that trust is eroded. Like they're never installing another app again. And now the project managers in the office are not getting the pictures that they're expecting. And now they eject to spreadsheets, and they eject to email and Google Drive, and like the whole workflow software end-to-end platform. That sounds great, but if one of those kind of Jenga pieces is pulled out, the whole workflow falls apart, and people eject to these other point solutions. So we had to really re-engineer the mobile app, and the second time around, it was truly offline first. And technicians, we quite literally just had to pull a list from Postgres. Thank you, Postgres, of all the phone numbers of technicians. Not sure if this is, legal. And we had to call them and apologize and say, hey, like, do you remember Coperniq? They're like, who? Can you just, open your app store and go ahead and download this and give us another chance? And then, of course, it reached kind of critical mass. And I think we won our hardworking technicians' trust back.
Was that a hard decision, or was it just kind of immediately obvious? Like how did you think about it at the time? Where you're like, all right, this doesn't work. We're gonna have to. We thought we were gonna get away with doing this in an easier to architect way, but we're gonna have to rebuild from the ground up.
Yeah, there was definitely, again, on the one hand, it felt like, wow, we built all this functionality, but it's so brittle, it's so optimistic and online first, where we really need this to be so pessimistically, aggressively offline first, that we had to rebuild a lot of stuff. But again, thankfully, because we had kind of a lean and mean team of one, there wasn't a lot of egos, wasn't a lot of like sunk cost fallacy. And the gentleman, he just basically was like, okay, let's roll up our sleeves, let's rebuild it. And then, what helped is that coincided with the time when we had this realization that we don't actually want full web mobile parity, back to the jobs to be done, right? And so we were able to really kind of like matrix style X-ray, see the heat map of features that are actually relevant and what we want to bring into this, new 2.0 mobile app versus what we just want to discard. And the things that we did elect to actually build that were like the 80-20 features, we ended up building them in a super robust offline first fashion. And so we ended up shaving probably about 80% of the code base, like on a lines of code basis, but it ended up being better and stronger and more, frontline grade than ever.
Yeah. It sounds like I hear a lot of there's like two themes. One is just like practicality about the best, and like not having ego and just having the best, like reaching for the best tool for the job and being open. And, there's an efficiency to using things that work. And the second is just a lot of these systems, like you do your best and then they get in practical context and you learn a lot more about what the constraints and requirements are. I don't know. Maybe I don't know if those resonate with you, and or you have other you think you've had other high level learnings along the way.
Yeah, what's interesting is what we've learned along the way about hiring and recruiting engineers, because like I mentioned, we didn't really have a Rolodex of friends that we could call, former colleagues, and be like, hey, what are you doing now? I'm doing Coperniq. Like, do you want to just code on weekends? So we had to kind of get scrappy and learn what is this archetype of engineer that we need. And early on, we hired a lot of very junior developers. And that's good, again, if you have no users and if you're just trying to, build out as many surfaces as possible and bring something to market. That's not MVP-ish in terms of maybe breadth and depth, but it's still very MVP-ish. It's a prototype, right? Just in terms of, how robust it is, how scalable. So we ended up having to rebuild a lot of the early day features just because we couldn't hire sort of been there, done that folks. If I could go back and give myself, an Abdullah from 5 years ago, a piece of advice, I'd probably say like find at least one engineer who's just, senior enough, who's maybe built out kind of end-to-end stateful. It doesn't have to be workflow software, but it has to be B2B software. To kind of architect that V1, I think we would have been able to move a lot faster. Not just in the early days, because in the early days, there's no users, nothing's breaking, that doesn't matter. But as soon as you get to that inflection point, you start hitting these, successive walls. And a lot of these things, like the known unknowns, could have and would have been avoided if we had someone on the team that was a little bit more senior. But conversely to that, having actually gone through that and acquired that scar tissue, we're actually able to realize that, well, maybe we should pat ourselves on the back, because as soon as we, raised our seed round and we're able to attract kind of, about Silicon Valley, but definitely Bay Area grade talent, a lot of the early folks that we hired, they were super good at one super narrow, super local, like think microservice hell, like 500 fan out style services. So they could build something super, super well, but they didn't have that breadth and that depth and that high level architectural view. And so they were almost, useless to us, unfortunately, as harsh as that sounds, because we really needed people who were not always traditional programmers or from programming background, like, institutional programming backgrounds, but really people who were tinkers. And what really helped, and I think this applies to most vertical software or vertical platforms, what makes a good engineer for vertical SaaS is not necessarily an engineer who's hyper massively scaled some distributed system, but rather a person with enormous like end user empathy for someone in the trades, for blue collar folks. So some people on our team, their parents owned small businesses, or maybe they had some small home improvement project, and then it just resonates, and they kind of get how the world of atoms versus the world of bits operates. And folks who are just tinkers and not afraid to build a lot of software, and make mistakes along the way, and reinvent wheels, where maybe someone with a more conventional institutional background would be like, oh, I'm just a Flutter engineer, or oh, I'm just a CSS HTML designer who codes, or like, oh, I'm just a Kubernetes guy. Versus these folks, these diamond in the rough folks, they're much more like, all right, let's roll up the sleeves, back end, front end, kind of the old school almost archetype of developer. Those kinds of folks. If you know them, send them.
Yeah, no, I know what you mean. I remember my career. I never really understood the distinction. I was kind of like, well, I write the software that needs to be written, sort of thing.
Exactly.
Exactly. And I think that what I talk to people a lot is both on the one is like, yeah, people get more specialized later in their career. They can make more sense in a larger organization where you need more specialization, especially if they have a specialization function that is like rare. Right. Like once in a while you get to a scale where you need someone who actually can write algorithms. I'm not sure how true that's going to be in the future. But the other thing is, yeah, like the fewer people you have on the team, the more leverage you need around the additional people you add, because it's both like, at scale, you can have an engineering culture where people are much more like, you have more capacity for development and bringing talent up to speed. But, if you're a couple people and you're hiring your third, like they need to just get to work. And there are junior people who can do that, but they're just higher variance and harder to vet because no one's seen that in practice. And so it's like a little bit easier with someone that's a little further along to tell that they know how to get stuff done. But maybe switching gears slightly to what is, I guess, like, I want to talk about like how much are you using AI both in the product with perhaps LLMs, and then how much does it change your internal coding workflows to use LLM supported?
Just internally, or in the product as well? Or
either. Let's take the product first. Have you gone deep on LLM usage?
Yeah, so it's interesting because if we were doing this, 6 months ago, 9 months ago, I would have said, not yet. We were obviously using AI internally and doing all kinds of, AI hackathons and seeing like, okay, well, let's just, branch off of main and like do something, like take a small surface of the UI and then like refactor, like what would this form look like if you had like a little Ask AI, button. So kind of like low level of autonomy, very much like, hey, just, send some natural language input to, whatever, LangChain, OpenAI, get structured, validated data object, and then just like, post it to your backend as if like someone just filled out a form. So we were doing a lot of those kinds of things and really developing, I think, muscle memory in terms of how to build with these tools. And that's why, a piece of advice I'd give to anyone, vertical, horizontal, is if you don't know what to do, don't just do something, because that's probably stupid advice, especially for folks that are doing like a very broad horizontal point solution. But for vertical software, what we found is we were like, heck yeah, we'll be a GPT wrapper, right? Because we saw on Zoom calls that time and time again, our customers were taking screenshots of Coperniq and pasting them into like, Claude or ChatGPT. And we were like, while we're building this muscle memory, while we're understanding where the chips are going to fall in this ecosystem, because remember 6 months ago, everything was changing like over and over and over again. Like LangChain was just getting, stable. So things were changing, the ground was shifting constantly. And so we were like, well, let's start with kind of the Ask AI style surfaces. And then let's drill deeper in terms of autonomy. There's a lot of chat, just natural chat interfaces in our app. You can imagine all those stakeholders, right? And the triangle, they all need to communicate with each other in the customer portal, internally, in the web, et cetera. So we were like, wow, this is a no-brainer. And this is a ChatGPT wrapper, but nobody knows. Our customers are, again, much more like the suspension of disbelief, and the magic factor is it's a much lower bar to hit. And if you can just give someone something where you're already the workflow software, so you're in a privileged position in terms of like the framing of the questions or the prompting or the formulation of some unstructured problem. Yeah, you put this foundational model in the middle. make it look like magic, make it look like your own, UI, who needs to know how it works under the hood, and then like output structured output essentially. That was just a huge, just a no-brainer kind of like insertion area for us for AI. And again, starting small and less autonomous, less, I guess, agentic is the fancy word, and building up to something more and more autonomous. We didn't know from day one what was going to be like our first, agent. And at the time, there were other startups that were announcing like entire agent armies, like, oh, we give you a CSR, we give you this, we give you that, especially for the trades. And the kind of framework that we developed around this is, let's stack rank all the different administrative back office jobs on 2 dimensions. One dimension is like, what is the opportunity cost, the cost of doing nothing? And like, what ranked high on that axis was stuff like, okay, the phone's ringing off the hook, the mom, the pop, everyone, the whole shop's at lunch, nobody's answering, and it could be just a customer with a simple level 1 or level 2 question. So this like inbound CSR use case was born. And since then, we've tried to expand it to like inbound, outbound, multimodal, but it started as just like an inbound, voice AI. And then another one I remember for us, earlier on was like an accounts receivables agent, collector agent. Again, just single modality email, only outbound, because again, these invoices are aging. The mom and pop shop doesn't have time. It's chasing new business. If we can just bring, $5,000, $10,000 a paid invoice, just put that kind of on the table, business owners are going to want to do that, versus a lot of people at the time I remember were doing like, BDRs for home services or outbound kind of, appointment schedulers. And in our industry, there's so much resistance and so much of like a Terminator effect of, oh my God, these, machines are coming from my job. So if we kind of try to go with the high hanging fruit use cases, I think we would have gotten a lot of resistance, versus the low hanging fruit ones. Folks are very receptive, and, the margins in this industry are razor thin. If you can give them just like, 20, 30 basis points, that's already gonna turn heads, especially if, in the early days, you're eating the foundational model, like token costs. We're just now starting to think about how to monetize this. But again, that wasn't the object in the early days. It was just like, how can we solve like kind of the Turing test and the uncanny valley of like, I'm never going to hire, I'm never going to replace my human workforce, versus like getting these contractors to open their mind a little bit to this technology.
Yeah, that's cool. That makes a lot of sense. It seems like, it feels like, I don't know, it's just like there's a lot of practical applications, and it's like kind of just staying on ceremony about not applying them in like in a smart, and I think that it does make sense. Those sort of bottoms up is where you get the momentum around leverage. Cool. Are you guys using it a lot internally? Like, has it changed your coding practices? Is it, like how deep is your org on AI coding these days?
Yeah, it's funny because we deployed, so when the model started getting good, we already crossed kind of the 1 million lines of code threshold, just like for the core monolith. So there was already a super high risk of just, kind of going YOLO mode, like in vibe coding. So we definitely like, we got everyone to install Cursor, obviously, but we were like, okay, strictly use. There's actually, someone should build like a linter or like, Husky, like hooks for machines, so you could, or for LLMs, so you could just like adopt these standard conventions, like get everyone to use the same model. Like I'm sure there's probably already like some version of Cursor Enterprise, but we had to quite literally slap people on the wrist and be like, okay, no YOLO mode. Thankfully, Cursor lets you monitor your, usage and who's doing tabs, who's doing like agent mode. And I remember in the early days, even with tabs, like problem is there's a lot of instant gratification to a lot of these models, where like if you're giving it a bug, you start solving like a super local problem, and then it makes these edits that touches these files that on paper check out. And like we're a seed stage startup, we don't have like 100% unit test coverage, so we don't have a way to have 100% assurances that anything is going to work after these changes. They look innocent, looks good to me, and then it ends up kind of chaotically backfiring all kinds of various ways, and you go on these wild goose chases. I understand I'm starting to sound a little bit like an AI hater, but that was just a wake up moment for us of like, okay, there needs to be kind of a process and a framework and like standard convention for the team. And we ended up writing like a kind of like a hello world or a readme for like how to use AI within Coperniq, and a couple of examples of the do's and don'ts. And I think right now I'm pretty proud of where the team is, where it's really like a good kind of, augmentation motion and a part of everyone's flow. My job these days is just to check to make sure that everyone's last, tab was within the last 24 hours. So I guess as CTO, if I do nothing else but that and make sure that everyone's using AI and using it uniformly, I can already start to sit back and see some of the human machine magic happen. So it's very fun. It's a weird time.
Yeah, I mean, it makes sense. I think there's a lot of like, when your code base is large, obviously that's like the harder end of the spectrum. And then B, like, people misperceive that there's actually like a learning curve there because it feels like you're just supposed to tell it what to do. But like once you actually dig in and understand how to use the tool in a more sophisticated way.
It's scary too, because like, at least I think I published some paper recently, like your brain really does atrophy. Like if you start over outsourcing thinking, like at one point you look back and you're like, okay, I have to actually debug this function. Like that's so scary. Like you get this like physical reaction of like, oh, I don't want to do that. Like I haven't done this in so long, or like I haven't in time wise, it may have been months, but it feels like, it's just your brain really, I guess, atrophies in those aspects pretty quickly. So the converse of that is like, how do you make sure that engineers on your team still are getting the hands-on, like bottoms up experience? Because like if you maybe this is a little bit of a sci-fi scenario, but like imagine 6 months, 12 months go by, right? And you have all these maybe mid-level engineers and they're accepting the diffs or they're doing the, code reviews. But how do you make sure that you can keep having a pipeline of junior engineers or mid-level engineers that are entering your organization, getting up to speed, getting to a point where they could be, fluent and supervise AI? But, the chicken and egg of it is that in order to be a good adjudicator, you actually have to build the skills bottoms up. And how are you building the skills if the bar is so high, right, for AI? So we're definitely in the early innings. Like this is maybe more the next generation of engineers concern. But I'm starting to see it like on a local scale, and I'm just thinking, how can we have practices and guardrails to make sure that folks like still keep exercising those muscles? So unsolved problem for sure, and new problem.
I guess the hard part is you're sort of expressing a view on how good the AI gets, because it's like, there's analog where you don't actually know how to write assembly, and someone does, and someone can check it somewhere. But like what becomes object code is an open question, and it's hard to tell because like, the current generation, obviously, like that concern is very valid. If someone doesn't like double check on a lot of things, like there's a lot of problems. But if you extrapolate on the trend line, who the hell knows?
Exactly. I mean, it's kind of like I was actually talking to ChatGPT the other day. I was like, how many people were at the foundation of like, Kubernetes or like Docker? And it's like on the order of 200, 500, people that actually understand how C groups and all this, like, hypervisors, how they work under the hood. So those people are not at risk of like getting rusty or forgetting how to code because they're always going to be, hands-on. So maybe there's an argument that, yes, like it's a levels of abstraction kind of thing, and we're just like doing the biggest hop yet. But something, at least to me, like when I use these tools, it feels like, wow, I'm starting to outsource a little bit of like my basic cognitive a workload, and it just just this friction I feel like in my limbs when I actually have to go. It's like, if you write a bunch of AI generated emails for a while and then you're like, you have to write a one pager, you're like, oh my god, like how am I going to do this? So I definitely feel it. I'm starting to feel that a little bit, and it's just, how do you make sure that you don't outsource too much of the, I guess, just human cognitive
I mean, it almost becomes a philosophical question at some degree, right? Like, because it's kind of like what do we know is important? What do we feel is important? How much is our cognitive bias around it? Like, obviously, do I still need to know how to do long division or calculate good enough? Like, what is the whole, like, where, and like, it's like this weird, you're picking a spot on the continuum while things are changing very rapidly. So it's kind of interesting time and space to think through.
Do you know if this is true or false? I was reading the other day that apparently Google, like, Fang Mang is now opening up a bunch of job posts again because apparently, they fired a lot of engineers and then they had a bunch of AI generated code and now they're having to hire humans is that kind of like
I don't know. I've heard things about both ways. I both also heard that like people's like support orgs have gone down in productivity, but that people want the AI so much. So I don't know. I think it's going to be messy, and I think it's going to be, I think it's also just very unevenly distributed. I think that like when I see the discrepancy of the people who've like dipped a toe in it and were like, oh, I asked it and it didn't work, versus like, you know, people that are like spending a lot of time getting prompting, working across a bunch of different modalities and actually like re-architecting the way they think about code and code bases to fit into the paradigm, as opposed to like trying to layer it on to what they're currently doing.
And it's like so sensationalized, like with like AI bears and bulls, that like, you know, it's important not to pay attention to the kind of headlines too much and just try it for yourself, for your team, and then just like be open-minded and at the same time understand like, you know, what kind of guardrails can you put on it, right?
Yeah, it is a balancing act. Cool. Well, what should we look forward to from Coperniq?
Well, we are right now, so I'm going to date this podcast a little bit. A bill just passed called the One Big Beautiful Bill. One of the sort of line items, second after Medicaid, was these, you know, energy tax credits, right? Renewable energy tax credits. So the solar industry historically has had a very interesting, you know, time and history with politics, because it's kind of like the parents are getting divorced and the child in solar is like the child going in between two homes. So it's like, you know, one administration comes and reinstates the tax credit indefinitely. Another comes and decides to like just, you know, crater the industry by like completely slashing it. And if people just left solar and renewable energy alone, I think it would have a much more healthy, much more like normal crossing the chasm S-curve style adoption curve, versus right now it's really like, you know, first it's stimulated, then it regresses. So this bill just passed. I was almost hoping that they would kind of rip off the Band-Aid. Of course, it would have been devastating for a lot of, you know, folks in the energy workforce, but at least it would have, I think, you know, the pendulum would have gone back to normal in terms of just normal market dynamics. But it looks like, you know, the solar industry is not going anywhere. It's not going to be like some kind of hard, that's a soft landing for sure. So, you know, Coperniq is going to double down on really kind of going up and down the value chain and making sure that instead of just, you know, helping folks at the workflow layer, the software layer, if we have to get into hardware and get our hands dirty, you know, so be it. But also just, you know, frankly, very excited about layering in AI. That's perhaps, you know, a little bit mundane or a little bit boring, but hey, if it helps cut soft costs in an industry that's historically been dominated by soft costs, I believe for every $3 that you pay for solar, $2 are soft costs, just permits, you know, overhead. So again, talk about an industry ripe for injecting AI to kind of trim the fat a little bit. So very excited about the constants of our industry, the software, the hardware, and now excited about this new layer in the layer cake of AI.
Sweet. Sounds super exciting. Well, thanks a lot for doing this. This is a really interesting conversation. Appreciate your time.
Thank you, bro. It was fun.
Awesome.